Welcome to Maths with Bob. Today we're looking at the rising and falling case. Our minion is going to be rising, getting up to a maximum height. We're going to find the time it takes to get to the maximum height, and then he's going to fall back to ground. Again, we'll try and work out his time it takes him to fall and his velocity when he reaches the ground. Obviously, no minions were harmed during the making of this video. Okay, so let's have a quick look. Okay, well, first what we have to do is generate the equations and go through the calculus of this. But a few people have asked me, how do we get the equation here? Let's have a quick look if I can get this pen to work. Okay. So how do we make it a bit bigger? How do we get this equation x double dot equals minus 10 minus v on 50? Now, well, the first thing is obviously the x double dot. Well, overall, I guess there's an m missing, which we've divided through each of these forces with, and but basically the x double dot is the net force, which is in the positive direction going up at this moment, and then we have got gravity coming down and a resistance. You can see here, which is minus v on 50. So the resistance is proportional to the velocity in this particular case. So we're going to have a look in the next video on the same sort of scenario with the resistance proportional to the velocity squared. But basically, if up's positive, the net force is mx double dot, and then we have an mg acting in the opposite direction, and the resistance is acting in the opposite direction. That's why they're negative, and then we cancel out the m just to get to this equation x double dot equals minus 10 minus v on 50. Now, what happens then? Well, we've got to use an expression for the acceleration, the x double dot, depending on what we want. If we want to get the maximum height, obviously we're going to need an x in the expression, so we use the v dv dx equals minus 10 minus v on 50. Now we do need to obviously basically separate the variables, so we need to rearrange this. First up, get some basically a fraction, put it all over 50, divide them by v, and then take the reciprocals of both sides. Okay, and we eventually get to dx equals minus 50v dv over 500 plus v. Now, then we do a bit of the physics and look at the basically the I guess the integrations and using our bounds. So basically what's happening here is, well, our height is going from, well, we don't know what the height is, so it's going from 0 to h, or some x value up to h, and we know that the velocity starts off at 60 because we are giving our minion an initial velocity of 60 meters per second. You know, gravity I'm going to take as, you can see there, as 10 meters per second. Okay, so we need to integrate this, and you can see here, well, I need to split it up first, and then integrate it, and it turns into a log for the height, and then we just evaluate the height from 60 to 0, and you can see here our minion goes up to about 168.78 meters with initial velocity of say 60 meters a second, and the resistance is proportional to the velocity in this case, and some people might say it's kv, and k is a 0.02 or a 50th if you want to think of it like that. Okay, so we now need to actually have a look at, if you like, the how long it's going to take. Okay, so let's actually have a quick look. Okay, so again, that's a bit of weird and wonderful. Let's get over here. Circle. Let's try over here a bit more. Didn't like that either. Okay, so let's try over here again. Okay, another weird one too. But anyway, all right. So again, how do we get the time basically? So, well, obviously we've got the same equation, but we now use, if you can see here, the acceleration as dv dt. So we want the time expression, so we use the acceleration expression with the time in it, dv dt, and again we work out what happened here. We just go, okay, put it over 50. We can take the negative sign out, invert or take the reciprocals of both sides, Okay, we get over here to dt is equal to minus 50 dv over 500 plus v. Okay, and then we have to integrate this expression here. So we're going to go from now. Well, the time is unknown, so this is why we're going from 0 to t. So this is some general time t. Okay, let's see if we get it here. Okay, so we're integrating dt from 0 to time, a general time t, which is basically going to get us up to velocity 0 at the top. Now, okay, so we know that it starts off at 60, so it's given an initial velocity of 60, the minion, and then when he gets up to this maximum height, we know his velocity is 0. I might not have mentioned that earlier, but at the maximum height, his velocity is 0, and that's how we put the bounds in. Now, okay. Now the time, obviously, is this log expression. We need to evaluate this log expression. Let's see here. Turns out to be what t is 50 ln, basically 5601500. It works out to be about, you can see here, t is about 5.67 seconds to get up to its maximum height of about, okay, 168 meters roughly. Okay. Now, okay, so let's have a quick look. Okay, so let's have a look at when he comes down. Okay, he's now going to fall. Okay, so he's actually falling down from his maximum height. Let's look at this. Oh, yes, it worked that time. It's quite finicky, this thing. Okay, so so what's happening now? Well, our minion has gone up to his maximum height, taking about 5.67 seconds to get up there. Go up 168.78 meters. Now, so okay, let's set the equation up again. Now, okay, what's happening now? Well, okay, he's falling now, and I guess you could say the positive direction is down, and that's why the 10 is positive, and the resistance is opposing the motion. That's why it's negative. Now, okay, so we use v dv dx equals 10 minus v on 50. Again, we just rearrange this. Take the reciprocals of both sides, separate the variables and then integrate. Now, when I was doing this, I did find out why a lot of textbooks don't do this actually, and you'll see in a minute why. Okay, basically we get this expression here. Okay, h is equal to, well, it's a transcendental function, and you can't really solve it because it's not algebraic in nature. So you basically have to solve it graphically. Okay, and okay, so basically, eventually we get that the velocity is about 55.87 meters per second. So this is actually a transcendental function. Okay, and I'll just show you GeoGebra. Let's have a quick look. Okay, so GeoGebra, I actually plotted the function, and you can see here that in fact the point A over here is actually 55.87 at 168.78. So basically, I just used the GeoGebra to graph it and try and work out the solution. So with transcendental functions, we haven't got much option really. Okay. Alright, so let's actually work out how long it takes him to come down from his height of 168.78 meters. Okay, so okay, no, didn't like that one either. Okay, so let's try another circle. This pen's a bit hard to control. Okay, alright. Okay, here we go. Alright, okay, so first up is, well, obviously we start with the same equation. Okay, let's go, here we go. Okay, same equation, x double dot equals 10. Okay, we're falling, right? 10 is positive, gravity is acting with us, minus v on 50, and you know the resistance is basically v over 50, or if you like 0.02 v. Okay, so again, we go through, now we want the time, so we use dv dt for the acceleration. We put everything over 50, take the reciprocals, separate the variables, and then integrate. Okay. Now, this one's okay. We can actually do this one, so let's have a quick look. Okay, let's have a look at the integral. Okay, so we integrate from, now, we're integrating 0 to t, so the general time, we don't know how long it's going to take to fall. But we do know that the velocity started off at 0. Obviously, when it gets to the maximum height, it's 0 velocity, and then it starts to fall, and it reached or attained a velocity of 55.87, which is well below its terminal velocity. And so the old minion, let's have a look. How long did it take him to fall down to that 168 meters? Well, basically, if you do the integration, it's just going to be a log. You just put the numbers in, and you can see here it's going to give us about 5.92 seconds to come down again. Okay, so you can see here it's about 0.25 seconds longer on the return trip. Okay, well, as you can see here, this is the up and down case. We're looking at going up to a maximum height and then falling back down to ground, and you can see here it's a bit longer on the return trip. Okay, well, that's all for now, and thank you for watching. Bye for now.